Hello everyone. So to begin with today's class, let us first recapitulate what we did in the previous class, and the topic that we are dealing with is trigonometric functions, and the question that I have on the board is somewhat like this. We have 3 sine to the power 4 3 pi by 2 minus x plus sine to the power 4 3 pi plus x minus 2 sine to the power 6 pi by 2 plus x plus sine to the power 6 5 pi minus x. Okay. Now, as you can remember, for certain quadrants, certain trigonometric ratios are positive, whereas negative as well. Okay. Negative in the sense, if in the second quadrant sine and cosec are positive, that means cos, tan, cot and sec will be negative. So keeping that logic in mind and what we did in the previous class, let us try to solve this question. Alright. So I'll write 3 as it is, and looking at over here, this value of angle 3 pi by 2 minus x, now this will fall in the third quadrant. Okay, this line is for 3 pi by 2, that means minus x is in this quadrant. Okay, so that therefore this sign value will be negative. All right, here, because in the third quadrant tan and cot is positive, whereas sine is negative. So that being said, now what we have over here is sine. This is odd multiple of pi by 2 minus x. So this sine converts into cos. Okay. And this power, I'll try to write it over here for simplicity. Clear? Alright. So sine to the power 4 3 pi by 2 minus x gets converted into minus cos x to the power 4. Now that being done, now same thing happens in the second case. We have sine to the power 4 3 pi plus x. Now this is a multiple of pi. Okay. Alright. Or you could say an even multiple of pi by 2. Alright. So this will remain as it is, sine x. But what about the sign? Okay, is it positive or is it negative? 3 pi means pi 1 time, 2 time and 3 time. This is the point 3 pi. Okay. Now what is being added? A certain value x. Therefore it comes in this region. Again in the third quadrant. So sine to the power 4 3 pi plus x will be written as minus sine x to the power 4. Alright. Now that is your first part. Alright. So minus 2, second part, sine to the power 6 pi by 2 plus x. As you can see, it is 90 plus x. 90 plus x means it is in the second quadrant, and in the second quadrant sine is positive. So we have sine converts into cos and the power is 6. Simple. Plus sine 5 pi minus x. Now again it is an even multiple of pi by 2 or an odd multiple of pi. So how many times? 5 times, 3 pi, 4 pi. Again over here, this is your 5 pi line. Okay. Okay. One turn, half semicircle or half turn, you could say it's pi. Okay. And a complete circle is 2 pi. So sine to the power 6, 5 pi minus x. Now this would be 5 pi minus x in the second quadrant. So this angle is in second quadrant. Now since it is in second quadrant, so it will be positive. Not just positive, it is an even multiple of pi by 2. Therefore, sine will return as it is, sine x. Now the power is 6 and the curly brackets closed. Simple. Okay. Now that being done, next step what we're going to do is we're going to simplify these two and then likewise in a certain method. So 3, the negative power becomes positive because of even exponential power. Okay. So this is cos to the power 4x plus sine to the power 4x, bracket close, minus 2. This becomes cos to the power 6x plus sine to the power 6x. Okay, simple. Now, further moving away, how do you solve this one? So to solve this, we need to take into consideration this formula. We have a plus b whole square equals to a square plus b square plus 2ab. Okay, or from here, if I find the value of a square plus b square, a square plus b square, this would be a plus b whole square minus 2ab. Alright, and similarly, a plus b whole cube can be written as a cube plus b cube plus 3ab into a plus b. So from here, a cube plus b cube can be written as a cube plus b cube equals to a plus b whole cube minus 3ab into a plus b. So in this fashion, we'll try to formulate this formula. Okay, clear? And try to solve it. Okay, so cos to the power 4x, this is in the power form. Okay, cos to the power 4x and sine to the power 4x. Now this can be written as cos square x whole squared. Okay, so it can be written as cos square x whole squared plus sine square x whole squared. Okay, minus 2. Similarly, cos to the power 6x plus sine to the power 6x can be written as cos cube x whole squared. Okay, or you could write cos square x whole cube plus sine square x whole cube. And we have a curly bracket closing over here. Simple. Okay, so that being done, now this can be compared to this form. A square plus b square equals to a plus b whole square minus 2ab. Okay, similarly, this form can be compared to this form. A cube plus b cube equals to a plus b whole cube minus 3ab a plus b. Likewise, in comparison, we can find that over here a is cos square x and over here b is sine square x. Okay, similarly over here we can see a is cos square x and b is sine square x. Simple. Okay, so this can be further simplified into cos square x plus sine square x whole square minus 2 cos square x into sine square x. Okay, now this part is broken down into this part. Okay, a square plus b square equals to a plus b whole square minus 2ab. Simple. Now same thing happens in this part. Okay, before that we have a value of multiple which is 3. Okay, similarly minus 2 bracket. Now this is in the form of a cube plus b cube. Okay, so this can be written as cos square x plus sine square x whole cube minus 3 cos square x sine square x into cos square x plus sine square x. Okay, so this form is what is being written over here. So a plus b whole cube, a plus b whole cube minus 3ab minus 3ab into a plus b. Okay, clear? Okay, so take a note of what's being done over here. We'll proceed further. Okay, so proceeding further, we can see that cos square x plus sin square x is over here, and same thing, cos square x plus sin square x, and then cos square plus sin x. Now from trigonometric identities, if you remember in class 10th, we had cos square x plus sin square x is equal to 1. So replacing that, we are going to have 3 bracket. So 1 squared is 1 minus 2 cos square x sin square x. Okay, close it. All right, minus 2 bracket open, again cos square x plus sin square x into whole cube is 1 again, 1 cube is 1. All right, minus 3 cos square x sin square x into cos square x plus sin square x is 1. So into 1, bracket closed. Simple. So if you open the curly brackets, we're going to have 3 minus 6 cos square x sin square x. Okay. We open this bracket, we're going to get minus 2 plus 6 cos square x sin square x. So something like that. So from here you can see completely 6 cos square x sin square x and 6 cos square x sin square x are like terms, okay, with a different sign. So what happens? They will cancel out and we are left with 3 minus 2, which is equal to 1. So the solution or the value of the expression comes out to be 1. Okay. So next we are going to talk about trigonometric ratios, their domains and range, and how they are periodic and within which interval they repeat the same function, same values. Alright. So the periodic nature of trigonometric function can be visualized through the graphs of the trigonometric function that we are going to construct here today. Alright. Now we have certain domains, and for that domain we have certain range for the trigonometric ratio sin x equals to y. So for various angles you have the value of the trigonometric ratio. Alright. For 0 we have sin 0. Okay, 0. Similarly for sin 30 degree 1 by 2. For sin pi by 4 1 by root 2. For sin pi by 3, for 60 degree, root 3 by 2. For 90 degree, sin 90 is 1. For 180 degree, sin 180 degree is 0. And for sin 3 pi by 2 is minus 1. And so on. Okay. It keeps on repeating. Now, over here, I have written for certain domain till 5 pi by 2. And beyond that, it still goes on without terminating. Okay. It keeps on repeating itself, okay, periodically. So how do we construct the graphs of the sin x? That we will see. So moving further, we are going to construct the graph of the sin x function, trigonometric function. We have certain angles 0, pi by 2, pi, 3 pi by 2 and 2 pi. And for the respective values of angle, we are going to locate the value y, which is equal to sine of the angles. Okay, so we are going to locate the range of the function. So for 0 we have when x is 0 we have y as 0. So this is the coordinate. Clear? So you can see clearly this is the x coordinate, this is the y coordinate, x coordinate, y coordinate, x coordinate, y coordinate. And likewise for construction of graph we need abscissa and ordinate, which are available over here. Okay, Now for the first abscissa ordinate, we have 0, 0, which is 0, 0. For the second, we have pi by 6 and 1 by 2. So pi by 6, this is 90 degree. Pi by 6 is 30 degree. So let's assume it is somewhere around here. Okay. So next point would be, let's say, half. Okay. This is the next point. And then as we move further, for pi by 4, the 1 by 2 is lesser than 1 by root 2, so it moves further up, slightly up. Okay, and as we move further, we have pi by 2 equals to 1. So pi by 2 equals to 1. This is the third coordinate plotting. Okay, and as we move further, pi by 2 is 1, so pi is 0. So again we reach over here. All right, now angle between these part is again repeating part, and what happens is it is equivalent of this angle, this ratio, and somewhere over here it would be same region. Okay, so for pi, sine pi is 0, which is over here coordinate, and as we move further, we have 3 pi by 2, which is minus 1. So minus 1 is over here, so 3 pi by 2 somewhere over here. Okay, now as we move further, again certain coordinates are over here, present over here. So next we have 2 pi. So for 2 pi, this is the coordinate. Okay, and as we construct, we come to know for certain angles between pi and 3 pi by 2, the coordinates would be somewhere around here. And same thing over here, between 3 pi by 2 and 2 pi, we have coordinates around here decreasing. Okay, clear? Now if you join all the coordinates, what we are going to get is something of a shape in this way. All right, now this form of graph is known as sinusoidal graph. Okay, and it finds extensive use in studies of harmonics, in studies of sound waves, in studies of pendulum, something that is periodic in nature. It finds its use over there. All right, now that being said, it does not end at 2 pi. Again, as I told you, that sine x is a function that is periodic, it's non-terminating. And by non-terminating, what I mean is, whatever be the value of x, you are going to get a value of y. However, in case of sine x, in case of trigonometric ratio of sine, the value will always be between 1 and minus 1. Okay, it won't go higher than 1, it won't go lesser than minus 1. Okay, so that means it will always be within the interval of 1 and minus 1. So it keeps on repeating like this. Okay, so in movies, as you see that the person, a patient that is about to die, so what we see is, we see the harmonics of their heartbeat, and how is it represented in the monitor is usually through the trigonometric functions. All right, moving further, next we are going to talk about the trigonometric ratios and the graph. And for sine x, as we talked earlier, it always rotates between, it always oscillates between the value maximum to be 1 and the minimum to be minus 1. All right, now same thing happens with cos also. Now cos trigonometric function has a maximum value of +1 and a -1. However, if you compare sine trigonometric ratios and cos trigonometric ratios and their graph, respective graph, we see that cos x is lagging behind sine x by a short distance of pi by 2. Okay, now what I mean is, over here we find that pi by 2, at pi by 2, sine pi by 2, the value is 1. Okay, but at 0 in cos x, the value is 1. All right, so as you can see, sine and cos, they are both having a difference of pi by 2. Okay, clear? So therefore, whenever we talk in class 10th about complementary functions, complementary in the sense we have sine pi by 2 plus x equals to cos x, or sine pi by 2 minus x equals to cos x, or cos pi by 2 plus x equals to sin x, cos pi by 2 minus x equals to sin x. Now the reason why it becomes sine, now the reason why it becomes cos is that we are adding up the lag or we are decreasing the lag. And how much is the lag? The lag is pi by 2. Okay. So if I add up the lag to the angle pi by 2 plus x, if I'm adding angle 90 degree, which is the lag, okay, so this becomes cos x. Okay, so you can understand this point through the graph. Since the difference is pi by 2 and we are adding the difference, which is pi by 2, therefore sine can be changed into cos. Okay, so that is the logic behind the complementary functions. Now, for the cos trigonometric ratio and the graph of it, you can see that it begins from plus 1 and it ends at minus 1. Therefore, the maximum value that the cos ratio, the cos trigonometric function can have is positive 1 and the minimum value is minus 1. Okay, so the range is between plus 1 and minus 1. Alright, now domain can be any real number, any angle starting from negative infinity to positive infinity, but the range will always be plus 1 to minus 1. Okay, now this is for cos trigonometric function. Alright, now for the tan trigonometric function, whose diagram is slightly different compared to sine and cos function. So you can see over here that the tan value is infinity at 90. Similarly, it repeats after certain interval. In this case, we have 3 pi by 2, okay, 270 degree, okay, again it's infinity. So if I plot this graph, I'm going to get something like this. All right, it starts from 0 and it goes value. So at 90, what it gets is, it gets a value of infinity. So since I cannot show the value infinity in the graph, what I'll do is I'll subtend this and I won't be joining it with 90 degree because it is not, the value is not legible or value is not valid. Okay, since it cannot be shown on the graph, so what happens is this line keeps on going in this direction and it does not meet in the 90 degree line. Okay, similarly for the second part, it is 0 at pi. However, you can see it is repeating, the graph structure is repeating and it's similar, but what happens is it is infinity at this point and then negative infinity at this point and goes on increasing towards infinity, and that point again it will repeat from the negative infinity and go up to the positive infinity. Likewise, for certain value it will have 0 value and so on. All right, clear? So this is the trigonometric graph of the trigonometric function tan x. All right, so that being said, we have trigonometric ratios, 3 more trigonometric ratios. We have cos sec, we have sec, and we have cot. Okay, now that part I'm leaving up for you and try to understand that, and the logic behind the plotting of graph is same as this one and we'll talk about it later. All right, so next we are going to talk about a random function that contains a trigonometric function as well. Okay, so by random function I mean in this function we have 3 cos 2x. Okay, now it's not a regular trigonometric function, however as you can see it is an inclusion of a trigonometric function. Okay, now this function has an included trigonometric function which is cos 2x now multiplied with 3. Now that being said, the cos function has a range between -1 to +1. Okay, so it has a range between -1 to +1. That means this function, which is equal to 3 into cos 2x, will also have a range of positive 3 to negative 3. Okay, so cos 2x alone has a range of minus 1 to positive 1. When that is multiplied with 3, we are going to have plus 3 and minus 3. Clear? So understanding that, let's jump on to certain values of angles that I wrote here. Now these angles are being written because you can see over here a 2 is being multiplied. Now since 2 has been multiplied with the angle, this is cos of 2x. Now angle is 2x. So if I replace x by 0, then this is going to be cos of 0. Now cos of 0 is value 1. So multiplied with 3 becomes 3. Okay. Similarly, we have pi by 12 over here. Now if you replace x by pi by 12, you are going to get 2 into pi by 12. It is equal to cos, which is equal to cos pi by 6, which is cos 30. Cos 30 we have root 3 by 2. So 3 into root 3 by 2, we are going to get 3 root 3 by 2. Clear? Similarly, moving further, cos 2x. For x we have pi by 8. Now if you replace x by pi by 8, we are going to get pi by 4. 3 into cos pi by 4 is going to be 3 upon root 2. Simple. Next, for x we have pi by 6. Pi by 6, if I replace it, it becomes pi by 3. 60, which is equal to half. So this would be 3 by 2. Okay. Similarly, if I replace pi by 4 over here, we have 2 to cancel, pi by 2. Cos 90 equals to 0. So this is going to be 0. Clear? So that is how we are going to replace the values, and we are going to see how other angles as well, or the values the other angles are going to give. Okay. So next so much. Similarly, angle pi by 3 is minus 3 by 2, and for x equals to 3 pi by 8, we have minus 3 by root 2. And likewise, we can calculate all the angles easily. Alright. Now that being said, if you try to plot the graph using the values over here, then we are going to get something like this. For this is 3 cos 2x along the y-axis, okay, and along the x-axis we are going to use the value of x. Okay, so for x we have certain angles which have been written over here, and for 3 cos x, let's say this is y. Okay, so this is the value. The maximum value that is possible in this case is 3, and the minimum value is minus 3. Okay, so from here we can write, when x is 0, y equals to 3. This is my first coordinate. When x is equal to pi by 12, value is 3 root 3 by 2, somewhere around 2. Okay, let's say somewhere around 2, not exactly 2, but somewhere around 2. Okay, so likewise it keeps on falling down. 3 by root 2, pi by 8, it falls down. Pi by 6, 3 by 2, 3 by 2 is 1.5, something like that, 1.5 in the center between these two lines. Okay, and then for pi by 4, what we find is, it is 0. Alright, so the graph is turning around something like this. Okay, now again it goes on moving till it is minus 3, and the minus 3 is for pi by 2. So this value is minus 3, goes on to get minus 3. Okay, so this is minus 3, this is plus 3, and then again it increases to 0 at 3 pi by 4, and then at pi we have value 3. Okay, and this way we are going to plot the graph of the function that is given to us, a random function that is inclusive of a trigonometric function. So this graph is again somewhat repeating and periodic. Alright. Any doubt? So this is how we are going to do with the graphs of the trigonometric function. That is all I have for you today, and hope it is clear. Even though to make it more clear, you need to practice more. Okay, and I hope that you'll be practicing it, and I hope there's no confusion left in this topic. Thank you.